Hey, this is Craig the Pool Man with Pool Specialist. Today we have a short presentation for you on basic pool electrical wiring. This is going to be in multiple modules because it's rather complex. So let's see how this goes. The first thing we're going to look at is what kind of agenda do we have? Well, I'm going to explain AC electricity, then introduce you to AC wiring code, the gauges or the sizes of the wiring, the different types of the wiring, and then some wiring examples. All right, if you were to look at electricity, i.e. like a geek on an oscilloscope, this is what it would look like. It is actually a sine wave. And this sine wave is, one sine wave is called 1 hertz. And of course, here in the United States, we have 60 hertz, which means that you have 60 of these every second. And if you ever hear that buzzing, that common buzzing noise, that's exactly what you're seeing or hearing, is you're hearing 60 of these in 1 second. If you look, this sine wave goes up to a peak and then down to a peak. Well, the peak up here is 170 volts, and the peak down here is minus 170 volts. Well, if you think about our electrical, it's called 120 volts. And so that is this line right here, which is what's called the effective voltage. It is also referred to as RMS, or root mean square. So when you take your digital voltmeter and you attach it to a 120 volt circuit, it reads 120 volts, because that's what these meters are set up to read, not peak to peak, but root mean square. Okay, so now the same thing but a little bit different is if we need 240 volts, we actually have 2 sine waves. And the one sine wave is 180 degrees out of phase with the other sine wave. And same thing, my effective voltage on this sine wave is 120 volts, call it positive. My effective voltage on this sine wave is 120 volts. So you add those together and your effective voltage is 240 volts. So when you hear on a regular residential system that it's 240 volts, this is how it works. So you actually have 2 wires coming in. The one wire represents this sine wave, the other wire represents this sine wave. And very commonly they will split them and you will see a black wire and a red wire. Okay, that would be normal for your household. When you start getting into commercial, it is called 3-phase. So here we have phase 1, and that's 120 degrees out of phase with phase 2, and then that's 120 degrees out from phase 3. So these are all unique sine waves. They're all separated by 120 degrees. So how does this actually calculate out? Okay, so there's 2 different types of 3-phase. The first type that we're going to go over is what is commonly used at the commercial, and this is called a Y connection or a Y configuration, as you can see here. Okay, so if you go from your neutral to any one of your phases, you get 120 volts, which would be normal for household voltage. But if you go across the phases, you only get 208 volts. That 208 volts is not enough to run single phase 240 volt equipment. So that this equipment will not function correctly or reliably on 208 volts. This is very, very, very important. And so if you are trying to put residential or 240 volt equipment in a commercial application, you are going to have problems. If you have the option to run it at 240 volts or 120 volts, you have to run it at 120 volts, because at least this way, from the neutral to the phase, you are actually going to get the correct voltage. Next is there's something called a delta connection. This is sometimes referred to as high leg, and this is less common in commercial unless the commercial is in a residential area. And then what you'll see is on some of the phases you have 240 volts between them, and on another phase you only have 208 volts. So if you are running a single phase pump, you have to be very careful that you actually connect it to two of the phases that are going to give you a 240 volt differential so that that operates correctly. Because if you connect it to this phase over here, which is 208, then that is not going to operate correctly or reliable. Again, you go from your neutral to any one, or neutral to two of your phases, you get 120 volts. So you also have to be very, very careful with this as well, because this is your wild leg or your high leg. And so therefore you don't want to be connecting, 120 volt circuit from neutral to this phase. So again, very, very important. Be conscious, you need to have a meter, you need to be checking your voltages in between your phases and make sure that you've got the correct phase. This will work fine if you have three-phase equipment. You've got your phase A, phase B, and phase C. So if you have a commercial pump or commercial equipment that's three-phase, this will work fine. There won't be any issues with it whatsoever. Okay, code or color code of AC electrical wiring, which is very different than DC. So your hot wire colors are black, which is your most common, red, and blue. If you're doing three-phase, this is typically what you're going to see. You're going to see black, red, and blue, isolating out and identifying each of the different phases. Sometimes in single phase, they'll use black on both the power lines. Other people will use black and red. Some people will use blue. All of this is acceptable. Your neutral color wire is white. And so the reality is, if I come in and I touch a black wire and a red wire or blue wire, I'm going to get knocked on my butt. If I touch a white wire, technically I should have no voltage there, because this is my common. This should be at a 0 volt level, although it can drift depending on what is going on in the system. Your ground wire is always green, and so in your typical circuit, 120 volt circuit, you're going to have black as your hot, you're going to have white as your neutral, and then you are going to have green as your ground. When you come into the pool world, we have a bonding wire, and that wire is bare copper, and that is connected to your pool shell. It's connected to the lights in your pool. It's connected to the handle or handrails and ladders in your pool, and it goes under the ground. It's connected to the rebarb in the concrete, and it goes to your equipment pad, to all of your equipment, including your electrical boxes, etc. Now, it is in actuality a separate circuit from your ground. However, what winds up happening is, because your ground is essentially hooked to the case or the metal of your pump, it the bonding is also hooked to the case or the metal of your pump through the bonding lug on the outside, where the grounding is actually inside with the other wiring. Okay, wire sizes. It's also called the gauge of the wire. And the gauge of the wire that you use is dependent on how much current you actually have to draw through it. The most common used across the board in the pool industry is 12 gauge wire. So the 12 gauge wire, if you go with the household type wiring, is good for up to 20 amps. If you go with the pool type wiring, which is over here in the right column, it's actually good up to 30 amps. So generally speaking, it does not behoove anybody to use anything but 12. So even in a 15 amp circuit, you're typically going to find 12 gauge wire. You could technically use 14 gauge wire in that 15 amp circuit, but nobody ever does it because everybody just uses 12 gauge wire. When you start getting up to a 5 horsepower pump, that draws quite a bit more current, and so therefore most people use 10 gauge wire for a 5 horsepower pump. And then depending as you go up in horsepower to commercial grade pumps, you're going to have to look at the current draw that you have, and then based on the current draw that you have, you will determine which gauge wire you have. When you're running the main into your actual sub panel, then you have to be very conscious of the fact that what gauge wire do I have? If you're running, a 60 amp circuit, well then you're going to have to run at least 6 gauge wire. And some people will even step it up to 4 gauge wire. So if you notice that this 18, 16, we're declining, as we decline in that number, the gauge of the wire goes up. Okay, next is we have household wiring examples. So this is not used in the pool industry, and you'll commonly see it. People that don't know what they're doing may use it. This is actually indoor wiring, and it's not rated to be outdoor. The insulation of this wire is not rated for the types of pumps and equipment that we use in the pool industry. Even the underground burial cable, which is okay if you're running, I guess, electrical boxes or whatever outdoors, we just don't use this in the pool industry. It doesn't meet our standards. I'm not quite sure you could pass inspection anywheres, even with the underground feeder cable. And then you also have to remember that the current draw through this is lower than the wire that we use in the pool industry. Pool industry wiring examples. In the pool industry, we use a much higher grade wire. You can still get this at Lowe's and Home Depot. Typically, we buy it in 500-foot lengths just because it's a lot more cost effective. You can use solid wire, or you could use stranded wire. There's advantages to both. We tend to use the stranded wire. It does carry a little bit more current, and it is a little bit easier to work with in the conduit and getting your wire to where it might need to be. It will also require you to have lugs on the end of the stranded wire, or preferably lugs on the end of the stranded wire, where you really cannot put lugs on the solid wire, and that's just going to go straight into the connection. Then that wire goes through conduit, and all the conduit that we use in the pool industry is waterproof. So we call this is flexible watertight conduit. A lot of people refer this to as Smurf conduit. And it comes in 1/2 inch, 3/4, and 1 inch sizes. So you would use these connectors on the end of it, and they would then get into your junction boxes, into your equipment, etc. And they would keep that watertight connection and also provide a little bit more insulation for the wire that's running through it. This way we can customize the wire we're going through it. If we need 3 wires, 4 wires, 6 wires, 8 wires, we can run that through our conduit. Then this is the flexible conduit, and of course we have our solid conduit, which comes all the way up to multiple inches. And this is an example of 1/2 inch, which would be equivalent to this 1/2 inch Smurf conduit. And then what happens is you use sweeps for your connection. There's no such thing as a 90 in electrical, because there is no way to get a wire around a 90-degree fitting like you would use in PVC plumbing. So you have to use this type of conduit. It's going to have these large sweeps. You can typically get the wire through 3, maybe 4 sweeps max. So when you're running this underground, keep that in mind. You also want to run larger pipe or larger conduit for longer runs. So the longer the run, the larger the conduit that you're going to use. So example is, you'll see that in the lights on some of the pools, that the better builders will run 1-inch conduit. Then that makes it a whole lot easier to pull the light wire through it, especially on long poles that might be over 100 feet. Most of the builders use at least 3/4 inch conduit on the lights. You really just cannot get away with 1/2 inch conduit on lights. So this is the hard conduit. All right, here we have an example of the inside of a Pentair Easy Touch load center, and we have just the main wiring coming into it. So you'll notice that we have the green wire, and that is attached to this lug strip, and you can notice that this lug strip is actually attached to the metal of the case. Then this is actually the bonding wire, which goes through the lug, and to pass inspection, that wire must protrude through that lug at least 1 inch. Next, we come back here, and this is my neutral bar, and so I have the neutral wire going into here, and these are actually isolated from the ground, so this is not connected to the ground. It's not supposed to be. In older houses, a lot of times these things are intermingled, and the ground and the neutral are one and the same, but the neutral should not be part of the ground. And you'll notice that I have the one hot wire going to this lug and the other hot wire going to this lug. So you'll notice that you'll see some connections here, 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 and here for this hot wire, and then for this hot wire here, 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 and here. That way, when we plug in a circuit breaker, which we're going to cover on our next module, that you'll notice that it will actually snap into the back, and then it will connect to the both sides of that power. So you push that in, it'll snap in. This is a GFI circuit breaker, so this white wire right here is going to be connected up to the neutral bar. But so you have alternating power, or phases, however you want to look at that, from one circuit breaker to the next, or one slot to the next slot. So each one of these represents a slot that could take up a circuit breaker if it's 120 volts. You'll notice that
You can see the actual copper wire above and below this terminal strip, and you'll notice that you could also see some copper wire here sticking out, some copper wire sticking out here, and some copper wire sticking out here. That is imperative that you can do that, because the last thing you want to do is be crimping down on the insulation and have a poor connection. And if you have a poor connection, then the electricity is going to arc. The arcing is going to turn into heat. The heat's going to turn into a fire. So inside this box it would be contained, but you would still be damaging the wire and probably the equipment inside this box.
Thank you for watching. I hope you found it educational and informative. If you did, please drop us a like. Please follow us, and have a great day.